we're going to be taking a look at Venn diagrams, and I know I kind of talked to you guys before this lesson, and a lot of you said you have done Venn diagrams before, so this should be a pretty easy lesson for you. We're going to jump right in. Not too much to talk about, really, just going to get into an example. And first thing we're going to do in this example here is we're just going to shade in the appropriate part of the Venn diagram that they're talking about. So at a high school, some students play soccer, some do not. Some play basketball, some do not. This scenario can be represented by a Venn diagram as shown to the right. The circle labeled S represents the students who play soccer. The circle labeled B are those who play basketball. And then the overlap would be the ones that play both. Okay, and then if you're not in the circle, you play neither one. Okay, so I think this will be pretty easy for you. You might even want to pause the video and try this and then come back and see if you did it right, if you do it in pencil. But I'll get my highlighter here. So you can just do it in pencil or whatever. You don't have to use highlighter. On the Venn diagram, shade the appropriate. So students who play soccer. So students who play soccer. How about highlighter? Come on. Students who play soccer would be everybody in this S circle. Everybody. Students who do not play soccer. Well, if you don't play soccer, you're outside the S circle. So that's everybody outside the circle. Outside the circle. Okay, that's this area here. And even those who play basketball. Anything outside the soccer circle. So all these people do not play soccer. Students who play soccer and basketball. That's just going to be the intersection here. In between. Students who play soccer but not basketball. Soccer but not basketball. So we got to be outside the basketball circle but inside the soccer circle. So that's going to be all these people right here. All right. Students who play neither basketball nor soccer. So they don't play either one of these, so they got to be outside these circles here. All right. You get the idea. I don't want to waste time on your video here. And students who play soccer or basketball. So one or the other. That means they could be in this circle or they could be in this circle. So anywhere inside the circles. Either one. You could play both. One or the other or both. That's what or means when they say or. One or the other or both. All right, so I think we got a good understanding there. I hope we got a good understanding there. Jump right into some examples with some actual numbers here. Calculate some probabilities. Using the scenario from above, suppose that 230 students play soccer, 190 students play basketball, and 60 students play both. There are a total of 500 students in the school. So total 500. I'm going to make sure that all my numbers add up to 500. From this given information, this is the only one you can put directly. 60 students play both. That's the only one that goes directly into the diagram, and that's going to be in the intersection. Okay, the reason why is because, see how they say 230 play soccer? That's the total of the soccer circle, but some of those also play basketball. So of these 230, some of them are included in this 60. So it's the S, the total of the S circle should add up to 230. So you actually have to do 230 minus 60 and get 170. And that's what goes here. This is the kids that play only soccer. These play both. Now basketball, similarly, 190 play basketball. But that's the total in basketball. So 190 minus the 60 that play both. Because these 60 people already play basketball. We don't want to count them twice. So we're going to make that 130. So that circle. So now if you check it out, this circle adds up to 190. This circle adds up to 230, which is what they said. 60 play both. So what goes outside the circle? Well, it's whatever's left over. I have 170, 130, it's 300, plus 60 is 360. We need to get to 500. So 500 minus 360, because that's what I have in here, and that's 140. All right, so there's 140 in the neither, that play neither. Okay, I just want to keep that 500 total there showing. Complete the Venn diagram. All right, so we did that. How many students play basketball but not soccer? How many play basketball but not soccer? Basketball but not soccer. That's 130. Okay, so they're in the basketball circle, but they can't be in the soccer circle, so you can't count this 60. You only count the 130. Suppose that a student will be selected at random from the school. What is the probability that the student plays both sports? Now, probability, again, we talked about this. Probabilities need to be a fraction or a decimal. You can't just give a number, right? So it's how many play both sports divided by the total. So 60 play both sports, and there's a total of 500. So 60 out of 500, then you could divide those out if you wanted to. Complete the Venn diagram to the right by writing the probabilities associated with the various regions. And all that is taking these and putting it out of 500. So, and then dividing it out. So we're going to take these, grab a calculator here. All right, so 140 out of 500, and that's going to be 0.28. And then 170 divided by 500, 0.34. And then 60 divided by 500, 0.12. And 130 divided by 500, 0.26. These are the only acceptable ways to do a Venn diagram, either with the actual number or with the probabilities as decimals, okay? All right, now, symbols. We're going to learn some symbols here for and, or, and not. And you may have learned these before. You may have seen and like this and then or like this. Well, in probability, and they call them unions and intersections, it's kind of the same thing. And instead of like this, it's an upside down U. Or is a U. And then not is represented by a complement. A not is a complement. So we're going to talk about that. So this is just, I don't want to bore you with reading this for you. The set of people who are Americans and have brothers is represented by the diagram. We already know that, right? The and is the shaded region right here. Okay? This set is written A and B, read A intersect B. So whenever you want and, say you want to find the probability, you would put that symbol, that upside down U, okay, and that's called an intersection, and that means and, basically. So whenever you see that upside down U, that means and. If it's an or, that means it could be anything in here, A or B. We talked about that in the opening there, right? That's written A, U, B, okay? It's read A union B, and the union means it could be anything. Your union means coming together. So anything in A or B or both, right? And that, if you wanted probability, you would write it probability of A union B. Now, when you say not A, okay, not A, not set A, that's called a complement. And that would be represented by A raised to the C power. A raised to the C. I know it's kind of weird, like why would you raise to the C power? That's just how it's just notation. You just got to get used to seeing it. So it's read A complement. A complement. And if you wanted the probability of not A, so the probability of not A is the same thing as probability of A complement. So if you see A raised to the C, that's A complement. That means not A. Anything but A. So outside the A circle, so anything in the shaded region. All right? That's just notation for you. We're gonna example 2 kind of goes through it for you just to show you. I got to move it over a little bit. Just to show you some examples here, okay? So we're going to go back to our pen here. Now think about cars available at a dealership. Suppose a car is selected at random from the cars at this dealership. Let the event that the car is a manual transmission be denoted by M, and the event that the car is a sedan be denoted by S. The Venn diagram below shows the probabilities associated. Okay, so here we go. Here's a Venn diagram, blah, blah, blah. What is the value of probability of M intersect S. Remember, intersect means and. That means both. All right, so that's going to be M and S. So that's going to be this one right here, and that's going to be 0.12. All right, complete the sentence using and or. Probability of M intersect S is the probability that a randomly selected car has a manual transmission. Blank is a sedan, and that's what we just talked about. It's and. So whenever you see intersect, it's and. What is the value of probability of M union S? Union means or. It can be anything in M and anything in S. So we got to add all these guys up here. 0.09, 0.09 plus 0.12 plus 0.6. And that's going to be 0.81. 0.81 would be C. Complete this sentence using and or. So how about a union? Probability of a union is probably a randomly selected car has a manual transmission or is a sedan. A union means or. Okay? What is the value of probability of S complement? S complement is anything that's not in the S circle. Remember, not S. Okay, anything that's not in the S circle. So this is in the S circle. This is in the S circle. The 0.09 is not, and the 0.19 is not. So those are the ones that are outside the S circle. That's 0.19 and 0.09. So we're going to add those together. 0.09 plus 0.19 is 0.28. That's going to be E. And then S complement. Oh, explain the meaning. Oh, we already did. Well, let's explain the meaning, though. And that would be anything, that would be cars that do not available in a sedan. Not available in a sedan. Okay? Just putting it in words. All right? So that would be, that's it. Okay. And we got this last page here, right? All right. 62% of books sold at an online bookstore are works of fiction. 47% are available as ebooks, and 14% are available as ebooks but are not works of fiction. A book will be selected at random. So let's fill in using the Venn diagram and find the probabilities. All right, so let's fill in our Venn diagram here. 62% of the books are sold at an online bookstore are works of fiction. So this circle adds up to 62%, 0.62. So I don't know anything yet. 47% of the books sold are available as ebooks. Again, this circle adds up to 47.47. Can't do anything there yet. 14% are available as ebooks, but not works of fiction. That's important. 14% are ebooks, but not works of fiction. So E, but not F. E, but not F. That's going to be right here, and that's going to be 0.14. Now it's kind of like a puzzle. I know that E, the total of E, was right here. 47% was ebooks. So this whole circle should add up to 0.47. So subtract 0.47 minus 0.14, and that's 0.33. That I know this must be 0.33. So then if this is 0.33 and the F circle had to add up to 62%, I take the 0.62 and I subtract my 0.33 and I get 0.29. All right, so this has to be 0.29, and you know that everything has to add up to 1, right? So what do we got? 0.29 and 0.33, that adds up to 0.62 plus 0.14. 0.62 plus 0.14 is 0.76. So 1.0 minus 0.76 is 0.24. So I know the neither part up here, anywhere on the outside, must be 0.24, are neither ebooks nor works of fiction. Now we can answer the questions easily. Find the probability that the book is a work of fiction and available as an ebook. work of fiction and available as an ebook, and that's the intersection there, and that's 0.33. The book is neither a work of fiction nor an ebook, and that's the 0.24 that we already found. So we pretty much already answered these. We just had it in our diagram. Return to the information given at the beginning of the question. 62% of the ebooks, blah, blah, 47%, 14%, blah, blah. How would this information be shown in a hypothetical 1,000 table? A hypothetical 1,000 table. All right, so let's do that. 62% are works of fiction. Now, they don't specify, so that's going to be 620 total. Now, we're reviewing a little bit our hypothetical tables. 47% ebooks. So here's ebooks. So that's going to be 470. So I know this must be 530 because these have to add up to 1,000. I know this is 380 because these two have to add up to 1,000. 14% are ebooks but are not works of fiction. Ebooks but not works of fiction. Okay, so ebooks but not fiction, and that would be 14%, so 140 would go there. So I know this would be 330. I know this would be 290, and I know this would be 240. Okay, and this all adds up, 380, this is 620, this is 470, this is 530, beautiful. All right, everything adds up. Complete the hypothetical, we already did it. And complete the table showing the probabilities represented by the cells of the table. So now we're going to do probabilities. So 330 would be 0.33. 290 would be 0.29. See, we're kind of going backwards from what we did before. We're turning them back into probabilities. But what's nice about this is it gives us every possible scenario that they can ask us. See how this works? I just want you to make the connection between the hypothetical 1,000 table and the probabilities. Okay, so this is kind of nice. In our last lesson, we went from the probabilities to the hypothetical table. Now we're going Venn diagram to the hypothetical to the probability table, two-way table. How do the probabilities in your table relate to the probabilities you calculated in Part A? Are they matching up? 0.24, right? There's my 0.24. There's my 0.29. There's my 0.29. My 0.33 and my 0.14. My 0.33, my 0.14. See how all four of those are going to be in the Venn diagram? So these are the four scenarios that will be in your Venn diagram. What's nice about the table is it also gives you the totals so you can do independence and all that stuff. And that's what you're going to be doing in class tomorrow. We're going to take the Venn diagrams, go to tables, and then answer some conditional probabilities and prove some independence or dependence based on the tables and these probabilities. I will see you then.